Right, APC, we're going to pick up where we left off. Again, this isn't going to match perfectly with our classes, but it's hard for me to predict what we're going to do when I'm making videos. So just for anybody who missed this, let's go ahead and find a sinusoidal equation for each graph. Okay, so sinusoidals can be sine or cosine, and we're gonna select the most obvious sinusoidal here. So, for example, we could think of this. I mean, it looks like cosine, right? Starting high, but we could think of this as a sine that started here with a horizontal shift and then went low. But why would we complicate our lives in that way, right? So we're just going to take the most obvious. Okay, so first thing you want to do is find a whole period. That's a whole period, so yay. And then you want to, look at the symmetry. So that's symmetric, so that means there's been no vertical shift. So I'm thinking cosine, and it's starting high, so I'm thinking positive cosine. All right, so f of t equals, that's an amplitude of 3, that's positive, because it starts high, cosine, and then no vertical shift, so all I got to do is figure out the period. Okay, so this is a max, and this is a min, and a max and a min will always occur in a half period. So I know for sure a half period there is 2 pi. So right here, even though it visually looks like that max to min will confirm that that's indeed a half period. So I would take 2 pi times 2, get my periods 4 pi. Now what is the b value? 2 pi over b is 4 pi. Cross multiply, divide it out. All right, so 1/2. And you can just get your common sense around that too. That if the period doubled, that comes from a horizontal stretch, and that comes from a 1/2 because you do the reciprocal. Okay, boom. That question is done. Let's go to the next one. So I'm going to pick up a piece here. I'm going to start. It's always nice if you can start at 0. So if you're at a max or a min or at the line of equilibrium at 0, then that's going to be your easiest function to pick up. So I'm going to just focus on one cycle here. Okay, I want to ignore everything else but that one cycle. All right, so that looks like a sine graph to me, and it looks like a negative sign because it starts at equilibrium and goes low. I'm noticing symmetry with 2 and -2. That means there's no vertical shift. So I'm going to go ahead and reflect the sine with 2, and then all I have to do is figure out the b value in terms of the period. So the period goes from 0 to 4, so that's a period of 4. So 2 pi over b had to equal 4. So 4b had to equal 2 pi. Divide 4 out. 2 pi over 4 is pi over 2. Throw that right there, and you are golden. Okay, next one is here. So this indeed looks like a cosine, a positive cosine, a complete cycle there. All right, but now I don't see symmetry from here to here. So what I want to do is figure out my line of equilibrium, like kind of the symmetry, the horizontal symmetry line here. So this is super easy. You could just take this, you could take the 3. I mean, if you wanted to do it math-wise, you could say 3 plus, you could do the midpoint, right? 3 plus -1 over 2 is going to be 1. And so it's going to be right here. You can also use your common sense and just see that that's an amplitude, or that's an even spread there of 2 and spread there of 2. So I like to draw that in there. So this lets me know that I have an amplitude of 2, because that's 2, and that's 2. And it also helps me with my vertical shift, because as the vertical shifts go on the values, so goes the vertical shift on the line of equilibrium. All right, so pretty confident in, you can always write y equals, which I just defaulted to there. Amplitude of 2 starting high, so positive 2. Cosine, I gotta figure out my period, but I know this is incurred vertical shift of +1 due to the movement of the line of equilibrium. Okay, so now I just gotta look at my period, and there's max, there's min, and that's a distance of 4 pi. So let's times that by 2, and now I know my period's 8 pi over 3. Okay, so to figure out the b value, I'm running out of room here. Let's see, we'll go over here. 8 pi over 3 is the period that comes from the formula. Let's undo the formula, 2 pi over b. So 8 pi over b is 6 pi. Divide out 8 pi. cancel, cancel, and that is a b value of 3/4. Okay, so throw that right there, box it, and done. Okay, next one, last one on this little bit. Minimum at pi/4, -4, and maximum 3pi/4. So this is gonna be half a period. So I want to skip over this point. You know, here's our 1, 2, 3, 4, 5. So max and a min, I want to skip over that there so that I can get half a period. Okay, so minimum at -4 and maximum at 2. Okay. All right, so there's that. And so let's go ahead and, you know, so right here it'll be coming. I want to complete this sort of cycle, but I want to find the line that I'm weaving around. So once again, I could add these up and divide by 2, or I could just count 1, 2, 3, 4, 5, 6. So 1, 2, 3. So we're going to be, the line of equilibrium is going to be here at -1. So again, you could do 2 plus -4 is -2, and then over 2, -1, or you could just count. Okay, so that's good. And so I want to complete this cycle. So we're going to be coming from the line of equilibrium down, hitting it here, here, and then back. All right, so now I can write my equation. So that looks like a negative sign with an amplitude of 1, 2, 3, 1, 2, 3, right? An amplitude of 3, negative, starting on the line of equilibrium sign, going down, so negative, that distance is 3, incurred a vertical shift of -1, and let's just find that b value. So this whole period then is, well, if I go from pi/4 to, you know, what is this distance here? Well, 3pi/4 minus pi/4 is 2pi/4, which is pi/2. Okay, so this has a period, a half period of pi/2 from here to here. And you could also think 45 degrees to 135 degrees, that's 90. And so my period then is times 2. I have a period of pi here. Okay, and so to save ourselves some time, the original period of sine is 2pi. It got cut in half. Okay, so instead of writing 1/2 here, I'm going to write 2 because it's the reciprocal. Okay, so that's just going to be 2. If you went through the formula, I just don't have room. If I went to the formula, I would certainly see that. So there's the period of pi, and that got cut in half, and that comes from a horizontal stretch of 2 of 1/2, which comes from the reciprocal of 2. Okay, so that completes. Yeah, that completes 6.4. Let's go to 6.5 and see how long I can go here. So we're going to do the tangent, cotangent, secant, and cosecant graphs. All right? All right, so let's develop tangent here. Let me autofocus. And let's see. We've got some values here. 0, 1, undefined. I'm just going for the quadrantals here. And back to 0. And I'm also going for the 45s because they're easy. Okay, so let's put those in. Okay, so undefined, when tan is undefined, then we have a vertical asymptote. Okay, and that's when the denominator is equal to 0. So we see that happening, you know, here and then consistently later on. So let's see if we can put that in. That's going to be pi/6, pi/4, pi/3, pi/2. Okay, so there's pi/2 there. And then 2pi/3, 3pi/4, 5pi/6, and pi. Okay, so there's that's a full period of tangent, but to graph that is going to be a little clumsy, and I'll show you why here in just a minute. Okay, so let's fill in our other values here. Pi/6, I'm going to use the trick, and this will be √3/3. And right here will just be your √3. Okay, So if I'm going to look right here, I'm at 0, 0. This is, we'll put 1 right about here. This is at 1. And, you know, root 3 is at about 1.7. So here. Okay, so our curve is, you know, right here. If I play dot to dot, I'm looking like this. Okay? And then we have a break with that asymptote. Moving over here, we'll use our trick of root 3 in the denominator. So that's root 3, and that's quad 2, so tan's negative. And this is root 3 over 3, so negative. Okay? So I'm going to put those values in. All right. So this is our negative 1, which would be right here. And I'm going to go ahead and put that at about 1 point. That would be 1.5. That there. All right. And then that's at 0. So I'm leaving out the over 6's just because root 3 over 3, you know, that's going to be 1.7 divided by 3. So it's just going to, yeah, I think we get a big enough picture going to 0. So there's that. So this is why this little period is not a great, you don't really get the feel for tangent with this. And this is typically not where, when you're looking at tangent, where a textbook or a video would show you the graph of the tangent. But that is the graph of from 0 to 5. But let's see what it looks like if we go backwards. So if I go to negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So I'm going to have another, if I go negative pi over 2, you know, you're down here. So that's going to be another undefined. We're in quad 4, so that's negative root 3, negative 1, and negative root 3 over 3. So let's graph those out. So let's go negative pi over 6, negative pi over 4, negative pi over 3. Let's add a negative pi over 2. All right. And so this is at negative 1. Okay. And then this one here is at right there. And we've got that 0. So this is what the tangent graph looks like. So typically textbooks will show you the tangent graph on a period of pi, negative 90 to 90, certainly 180. That's a period of pi. And they'll show you this graph. Now, you know, mine's not curving exactly beautifully, but let's show you maybe on, oh no, I don't have my screen set. Let's show you here. So if I go clear tan of x, okay, and there, so there's what you can see. It's going to be concave down, hit this point of inflection, and then go concave up. These lines here on the TI, those are your asymptotes. The TI shows them as these solid black lines. So you have to know what you're looking at with the TI. Okay, and the other place you could see it is if I went this way. So if I went to 7 pi over 6, and then went to 5 pi over 4, I'm going to run out of room, and then went to 4 pi over 3, and then 3 pi over 2. I'll squeeze that in. You would have an asymptote at 3 pi over 2. Okay? And then, again, this would be in quad 3, so it would be positive 1, and then this is that 1.7. And so, you know, the curve's coming up. I could try to make it better. I put too much curvature right there. It's because this scaling is kind of, on these notes, is kind of, it's hard to make it work because it's badly scaled. It's sort of like, kind of like that. That's a little bit better. Okay, so CC down, point of inflection and up. All right, so there is your tangent. And again, this is all CCD, POI, and then CCU. All right, so let's answer some questions here. Of tangent of 120. Okay, so tangent of 120. So this is just your, you know, if you were to think of, this is 2 pi over 3, which is right here, it's right there, and that's your negative 1.7. A tangent of negative pi over 6, so that's going to be root 3 over 3, because you see that 6 right there, and go that way, that's quad 4 negative, and tangent of 3 pi over 2 is undefined. You can see that here. Limit, this just kind of, forget this, you'll see enough of this next year. This just is saying what happens. The limit is kind of like what happens. What's the behavior? as the angle approaches 0. As the angle approaches 0, what's happening? Well, the graph is heading to 0. As the angle heads to 0 from the positive side, what about as we head to 0 from the negative side? As we head to 0 from the negative side, well, we're heading towards 0. So you might be like, okay, that's kind of a weird question. What happens as we go to pi over 2? And if there's no sign there, what happens as we go to pi over 2 from the left and from the right? Boom, boom, this is undefined. All right, so the domain of tangent then is all real numbers, except we have to exclude the asymptotes. We have to exclude pi over 2, negative pi over 2, 3 pi over 2. Okay, and those are differing by the period of tangent, which is pi n times. Okay, the range is all real numbers. There's no max or min. This is strictly increasing. Okay, so let's jump over here. For what values of t on the interval is it decreasing? None. Tangent is strictly increasing. Okay, and that's monotonic. That means if you're strictly increasing or decreasing, that word is monotonic. All right. So you can see we're symmetric with respect to the origin. That's odd. We have already talked about that in our identities. We repeat every pi. Okay, and your vertical asymptotes will always be the same as the domain restriction, except you'll say what they are instead of what they are not. Okay. All right. So let's answer these questions. Describe in words the relationship between t and tan t in quad 1. As t changes from 0 to pi over 2, the value, so from 0 to pi over 2, the value goes from 0 to undefined. Be able to do that on the test and other quadrants. Last one here, on the interval, negative pi to pi, when is tangent 0? Okay, so that is going to be 0 at negative pi, and this is kind of tricky. Instead of going to 0 to pi, they've made us go negative 0 pi, pi. If I had to do that for all, this is A, B. Those are just, that's just pi to 0 to pi, so that's just pi times n to write it effectively. Where are we negative 1 from here to here? Okay, so sometimes it's helpful to think of that as negative 180 to 180. Okay, so I want to go to negative 1, so that's going to be at a 135 degree. And that's also going to happen to quad 4, but I can't give 315 because that's not between those, so I have to go in the negative direction and say negative 45, and that lands in between those. Okay? And so to cycle that, just take that smallest one and cycle it by the period of tangent, which is pi, and then n. Okay, the last one here. A, where does this happen? Root 3, so that's going to be over 3 and over 3. Positive quad 1 and positive quad 3, but that goes past this 180. So I can't give that 60-degree angle. I can't give 240 here. So I have to go in the negative direction and give negative 120. And to give all values, I just take the smallest. You don't have to do both with tangent because it has that nice 1 to 3 same sign quadrants and 2 to 4 quadrants same sign. So this one is in every other type situation, so you can simply cycle it by pi n. All right, so that is the end of the notes, kind of split, but yeah, that's the end of what we did in class. All right, and we'll pick up on the next video. All right, bye guys.